All right, so I want to just go through here a little bit of the notes. You're going to start on section 3A, looking at logarithms. And the big question is, what is a logarithm? And so I just want to start and just say, let's compare two equations. Let's look at 2x equals 8. If I asked you to solve that for x, you would tell me that you would need to divide by 2. So in order to solve this, you would divide both sides of the equation by 2, and you would tell me that x equals 4. Now, why did you decide to divide by 2? Why do we use that to solve? Okay, and hopefully you're thinking, well, we divide by 2 because we want to undo the multiplication that's going here. We want to use the opposite or the inverse operations. The opposite or the inverse of multiplying is to divide, and that's why we divide by 2. We get an answer of x equals 4, which is true. Now, if I change the equation, and instead of saying 2x equals 8, I say 2 raised to the x equals 8, well, how would I solve that? Okay, well, to undo an exponent is to take a log. Okay, so the inverse of, we call it exponentiation. When an exponent is involved, the variable is the exponent. The inverse of exponentiation is called a logarithm. So to solve the equation, we write it out in a log form. We can say log base 2 of 8 equals 3 is the same as, written in exponential form, 2 to the third power equals 8. So in this case, to solve this, 2 raised to what power equals 8? We would say, in this case, x equals 3. But I have to use a logarithm, or I have to use the inverse operation in order to solve that. So we have two forms. We have what's called exponential form. And in exponential form, we would write something with a base. A is called the base. It's raised to an exponent, and you get the answer. So if I went back up there and I said 2 to the third power equals 8, okay, 2 is the base, correct? 2 is the base, 3 is the exponent. That is written in exponential form. Okay, if I write it in logarithmic form, it shows that the log of the result of the given base equals the exponent. So again, since this is the base in the exponential form, it's also the base in the log form. So this would be written as log base 2. That 2 is a subscript. It's written down below the word log. Log base 2 of 8 equals 3. Your exponent is what it equals. Okay, so these two are equivalent to each other. This is just written in exponential form. This is written in log form. Okay. All right. Now let's go on. Whoops, I got to go back and get rid of that. Clear my drawings. Now, what you're going to do today is two things. You're going to, number one, convert. If it's given to you in exponential form, you're going to write it in log form. Or if it's written in log base form, you're going to write it in exponential form. Okay, so it says, what's the log form of 3 raised to the 4th power equals 81? Well, the question that you have to ask yourself is, what's the base in that equation? What's the log base? I'm sorry, what's the base of the, which number here represents the base? Well, that would be the 3. So you want to say log base 3. So you'd write the word log. That stands for logarithm. The base is a subscript. You write it just a little bit below. So log base 3, and then I put 81, and it equals the exponent. The exponent in the problem is the 4. So this exponential form looks like this in log form. Okay, go ahead and do letter B. What's the log form of this? Okay, hopefully you've already started to write the word log. Okay, what's the base here? Well, that's the base is the 7. It's what's being raised to the exponent. So it goes down here as a little subscript. And then I put 343. And it equals the exponent. The exponent in that problem is the 3. Okay, these two are given to you with the log. These are in logarithmic form. You need to write it in exponential form. So as I read this as log base 10 of 1,000 equals 3. So log base 10, that means 10 is the base. Okay, which of these numbers represents the exponent? Hopefully you said the one with the after the equal sign. So it's 10 to the third equals 1,000. That is that log form written in exponential form. And then this one, the way that I would read this, what is the exponential form of log base 4 of 16 equals 2? So the base is the 4, the exponent is the 2, and it equals 16. Okay, so you have several questions on your assignment, maybe about half of your assignment. You're either going to be given it in exponential form and they're going to ask you to write it in log form like this, or they're going to give you the problem in log form and they're going to ask you to convert it to exponential form like that. Okay, the other half of your worksheet is going to be solving or evaluating a log without a calculator. Okay, what is each log expression? Okay, what's the value? So what we want to do, we're going to take each problem and we're going to say, okay, this says log base 5 of 25. And if you want to, you can make an equation out of it and say it equals x. This is what we're trying to find. We're trying to find the exponent that we need to make this a true statement. So it's log base 5. So we're saying 5 raised to the power of x equals 125. Okay, so you're asking yourself, what power do I have to raise 5 to? 5 to what power equals 125? Some of you already know the answer to that. Some of you know that the answer is 3. X equals 3. Okay, and there's nothing more to do. You've solved it. The value of that log base 5, 125 is 3. Okay, something like this. We've got a fraction. This is log base 1/4 of 16. If I set that equal to x, whoops, what that's saying is I'm going to take the fraction 1/4 and I'm going to raise it to what power? So you put x as the power. And what is that power so that it'll equal 16? Okay, well, recall, this is a fraction. What do we have to use for an exponent for the fraction? In order to flip that fraction, the exponent has to be negative. Okay, so we're looking for a negative number. And what would I do? What exponent would make 4 into 16? Okay, hopefully you said a 2. 4 squared is 16. So it's got to be negative in order to flip that fraction. So it's going to be a negative 2. See if I can. Oh, my pen just went dead there. It's going to be a negative 2. Okay. So you're going to continue on this line. Here it says log base 2 of 2 to the 8th. Okay, so in other words, you're saying what this equals x. Okay, so I would say log base 2 raised to this exponent of x equals this part, 2 to the 8th. Now, when you look at that, that looks a little bit different. 2 to what power equals 2 to the 8th? Well, since they both have the same base of 2, we're looking for x to be equal to 8. So if you go back and look at that beginning problem, when it says log base 2 and then there's a 2, they kind of cancel each other out and x just equals 8. Okay, you might want to go through and just check. Oh, actually, let's look at f. Okay, we do need to look at f. If I said log base 7 of negative 7 equals x, 7 to what power equals negative 7? Okay, and this is one if you put in several numbers. If you want to put in a negative number here, if I put in a negative 1, remember a negative exponent does not produce a negative value. It produces a fraction. 7 to the negative first would be 1 over 7. Okay, if I made it -2, that would be 1 over 7 squared. Nothing that I plug in as an exponent is going to give me anything that's negative. So this is undefined. We cannot do this problem. Okay, so when you start working with logarithms, you're going to learn that this value right here cannot be negative. If it's negative, we cannot evaluate that logarithm. It is an undefined value. Okay, the rest of them, I think you should be able to figure out, and then you can work on the worksheet. Again, Zoom with your questions. I'm going to hold a Zoom, so make sure you join it. Be happy to answer your questions.